Hey guys, this is Paul, Inventor 3, and we're back at it with the free energy from air. The weather's finally starting to change and I'm able to get outside. Pretty excited about this, so we're going to be working on this again, hopefully trying to improve this. In the last video series I had of this, you could see we got 21 LEDs lit. Here's my setup. You gotta look at those lights right at the right angle there. You gotta keep in mind that it's daylight out and I got this white background too. If it was nighttime I could see those lights all the way across the yard. But here's the voltage across there. 2.4 volts. And here's our current in series with the load, all the LEDs, and that's 23 microamps. Alright, I'm going to be showing you everything today real quick here, and then I'm going to tell you what I'm going to be working on next. Alright, here's my collector. And I'm going to show you guys drawings and schematics and everything here. That box, there's one wire. Probably very difficult to see it. It's up there somewhere. It's hard to see it in my viewfinder. I can see it with my eyes. Alright, but anyhow, that comes over here. Whoops, to our pole. So we got an antenna. It's not touching any of those branches. Going from our box all the way over to the top of this pole. I've got one string there to insulate that wire from the pole. Okay, and that antenna wire comes down to that green wire to a coaxial cable that goes into the lab there, to our circuit. And I'll be showing you the wiring in a minute. And that white one coming out is actually going to that ground rod. That ground rod is 5 feet above ground and 5 feet below ground. Now I do have two of these rods, one at each end of my laboratory. There's another one down all the way at that end. Can't even see it through the weeds right now, but it's the same thing, 5 feet above ground, 5 feet in the ground. So they're both connected to each other. Okay, let's go inside. Okay. It took me a few hours to draw all this up. Pause the video where you need to. Oops. This is our collector box. It's on our roof. They're 12 inch by 12 inch plates. There's 10 of them. They're all connected in series, 14 feet high on my roof. There's a copper funnel on the last plate here. And I actually have a hole in the plate too, where that copper funnel connects to it. Here's my antenna, enamel coated wire, magnet wire, also known as or called transformer wire, 22 gauge, approximately 57 feet long. Now here's my pole. It's 16 feet tall. If you notice, my roof is actually 2 feet lower than this end. If you get this end a lot higher, or any of these higher, you're going to have a lot more energy. But I'm trying to do it like this because I want this to be a practical setup. I believe when I have things correct, I'm not going to need a collector any bigger than the size of a dime. Alright, so there's 3 circuits here. Here's the Joe Tate AMP or APM circuit, ambient power module. Okay, and that connects to a Cockcroft-Walton multiplier, and that connects over to this other last circuit here, which is a lid motor from YouTube. It's his, what he calls a penny circuit, his oscillating circuit. These are my LEDs over here. I did not draw all 21 of them. Okay, here's bucking coils. They have to be wound this way. One's wound that way, one's wound the other way, so that they buck against each other. It's like putting two magnets opposing each other, repelling each other. Let's see. There's one other little change I did in here, and I'll show you that. But here's another scan. Oh, let me give you a shot of that. Like I said, pause the video as you need to. Okay, here's the whole circuit again. This is our ground rod. I've only got one drawn, but actually we got another one way over here, and they're connected to each other. But just so you see how everything's wired together. Okay, now let me show you here. This is the parts list. So again, pause the video as you need to. There's lid motor. Let's see. I have a ceramic disc capacitor here. Lid motor used a square shaped capacitor here. I'm not sure what voltage rating it had. I forget what those square capacitors are called or what. Anyhow, here's my potentiometer. I got a 50 kilo ohm. He used a 1 mega ohm. I suggest using the 1 mega ohm to give you the wider range, because I used a 50 kilo ohm, and then I put some more resistors in there to experiment with. Anyhow, those coils. Oh, lid motor used twist tie coils of an unknown value. But anyhow, I'm giving you the value of the coils that I'm using right here. Ferrite rods, LEDs. Okay. So you got that, guys? Let me show you the circuit again. Again, 2.4 volts, 23, 26 microamps, fluctuates a little bit. Here's my coaxial cable and the ground coming in, the white and black wires. This is the AM Joe Tate circuit, Cockcroft-Walton multiplier, down to the oscillator circuit. There's my bucking coils. Now here's one thing too. Notice my potentiometer here is not connected. That's why I just have this going to nothing. I was experimenting with different resistors in there, and actually I'm getting the most power out of this circuit without having this connected right now, just like it's laying there. Otherwise the voltage drops down dramatically. So I keep getting lucky and experimenting with just the right things or something here. And then my bucking coils. You can see everything's kind of color coded color coordinated there with the alligator clips. You could kind of see I got the meter clips in there too. But I gave you the schematic. That's what I have going on here. It might be kind of hard to follow all these wires with your eyes right now, but this is basically what I have. Between seeing this and the schematics, you should be able to get it. This is where I experiment too a lot with ferrite rods. There's some fatter, shorter ones down inside there too. And I did a lot of experimenting with getting the rod, just, you know, tuning it. And there'll be a sweet spot where you get the most energy out of everything. So, okay, that's about it right now. Let me show you, those lights are on 24 hours, 7 days a week, unlike solar power. Now let me show you what I'm going to try next here. Okay, this is what I'm going to attempt to do now. I forget what they call this antenna, a dual bipole antenna, or I forget. Tri antenna. So instead of just one wire, I'm going to have one wire going to 3 wires. And I am actually going to put some wood supports in there at a couple places to keep those wires separated apart and at a certain distance as to not interfere with each other. So that's what we're going to try to do today, and I expect this will absolutely increase our power. Just how much, I'm not sure yet. Okay, finally got it. Sunday afternoon here. Branching off to there, I got some sticks there. They're dividing the antenna. But this is hard to see on my viewfinder, but hang on one second here. Comes over here to my pole, and let's get a better view of that over here. Let's see here. Where's my pole? There's my pole. There we go. That one wire in the middle coming down the pole is my antenna wire. Connected, soldered to a green alligator clip, and I'm going to connect that pretty soon to that black coaxial cable there coming out of my lab. Alright, let's see that again up here. Oops, zoom out. And you could see right there. Oops, where is it? Oh, there it is. There. One wire going to 3 wires. And then, let's see. Right up here and right down here are strings kind of holding this stick horizontal there. It branches into 3 wires then. It goes there, there, and over there. They're leaning a little bit there, but they're actually not touching the roof. And if anything touches the roof, the end of the stick will, not the wires. So the only thing we got, we added actually 100 feet more of antenna wire plus 6 little sticks, so there's a lot of weight now. So I got 100 feet more antenna in the air, but we're drooping a little bit more. So okay, here's my schematic again. I had 57 feet. Now that I had a chance to measure it, it's actually 62 feet from the end of the collector to the pole here, and then another 9 feet approximately going down here. So this is what we got now. So we had just one wire all the way here, but for 50 feet we now added the second wire here and a second wire here, and this is a wood support, and a few more inside. There are 6 wooden supports. So yeah, we're adding 100 feet more. So let's see how this helps to increase our power here. Okay, let's see. Alright, my wife just yelled at me now. She sees the antenna on the roof. She's freaking out. Okay, let's turn our meters on. There's the voltage, DC voltage. Here's our amp meter. It's set on microamps. Lights won't come on unless I have that meter on because it's in series with the load. So, but right now I'm going to set the camera up on these lights so we could see what happens, because I'm going to have to go outside and make the connection here. Hold on. Okay guys, I'm going to leave the camera recording here. I'm going to step outside my lab and make the connection. Let's see what happens. You get to see it before I do. So alright, here we go guys. Let me walk outside and see what we got. What's going on? What's going on? What's going on? What's going on? I see nothing. Wait. What's going on? What's going on? I see no light. It's scaring me. Okay, hold on. Let me check connections here. Wait, hang on. Hang on. 5. I had a lot more current than that, so that's concerning. This type antenna, I read that this type of antenna is supposed to give us more current. Lights still are not coming on. Alright, well, a lot of work for, yeah. Alright, well, we'll have to check things out here and see what's going on. I'm going to play around with this for a little while. Okay. It's a week later. I just plugged in the antenna here from outside. Let's see what's going on here. Lights are not on. Okay, so what are we going to do here? Well, that triple antenna thing is not working for us. So, yeah, the current went way down. I'm thinking about just switching out, putting my original antenna back up. But first, I think I'm going to try cutting out the middle antenna, leaving the 2 outside lines. I just turned my meters off and back on. Now I'm getting 30 microamps. So I'm wondering if my meter is acting a little fishy. Or component went bad? I don't know. I still do not see these lights lit up. Alright, let me analyze this and I'll be back. Okay. I had a loose ground wire outside. Let's see, I do not have the load connected up right now. What the heck just happened? 3 volts, 4, there we go. We were just on 7 volts. It jumped down for a split second there. Alright, let's see here. Alright, but we got better results now. Now I'll have to connect that load back up and see what happens here. Let's see how high that goes. Is it going to dump some of its energy? See, 7, I think it was 7 point something volts, and then it jumped down. Seven point 7. Oh, there it goes. So that tells me that's something with the capacitors here. Oh, we still don't have our load on. So alright guys, now things are different. Completely different. Alright. 5. It'll probably get up close to 8 again and dump it again. Because of that oscillating circuit there, that modified Joule thief. Let's see if it dumps the energy again. Capacitors or something there. Let's see, 7, 0.3, 0.4, 0.5, 0.6, 0.7 is about where it happened. There it goes. Yeah, alright. Alright. Yeah, let me connect the load and maybe the current meter again, see what's going on. Okay. Just connected the amp meter back up. 2.4 volts. And like fluctuates 37, 38 microamps. Yes, there's our babies. Like I said, it's really bright out right now, but now they're lit. Wow. I guess the when I put up that new antenna, that I must have bumped a ground wire or something. Wow. Alright, but we got like 38 microamps. And I still have it written on a piece of paper back there, but before I put that new antenna up, we were at 2.4 volts and 26 microamps. I forgot that other number was there. It's probably when I started having problems. So now with that antenna, like I said, it should have given us more current, and it looks like it did. Not much, but it did. Okay. Whew. Wow. After a week later, it did work. And the lights are bright now. Okay. So now, okay, let me think about what to do next. Now that we got things working and that antenna does actually work up there, it did give us more current. Like I said, not much. 10 microamps. But it gave us something. Alright, so now to rethink of exactly what experiments I want to do next with this. Okay guys, probably messing around with the coil over the ground again like I've done in the past. Yeah, anyhow, okay, let me think about this. Cool. So, success.